Today I'm going to be making Tom Hull's Five Intersecting Tetrahedra. It's pretty famous in the math community, so you may have seen a picture of it somewhere. It's known as one of the most difficult origami models, and it's one of the first that I've done. Is this a foolish endeavor? Possibly. But here we go. First things first, we'll need 5 different colors of paper. You could also do it all in the same color if you want, but that's for the experienced, so not me. I'm using origami paper, although construction paper would work too. The advantage of using origami paper is that we need to make rectangles of a ratio 1:3. So if you start out with squares, you can just cut each square into thirds lengthwise, like I'm doing here. We'll need 6 strips in each color for a grand total of 30 strips. So for each color, we'll cut up 2 squares of paper. Now that we have 30 strips of paper, we get to fold them all. First, we take a strip and fold it in half lengthwise. Then we bring each edge to the middle fold to create these barn doors. Now we go to the left end of the strip. Bring each edge to the center of the strip to create a small crease on the left end. Then bring the lower left corner to the uppermost crease. Fold the upper left corner over this one to create a pointed end. Now unfold the 2 corners and tuck the lower one inside. Then we'll rotate the strip 180 degrees and do the exact same thing on the other end. If you got lost in any of that, I've linked the PDF of instructions that I used down below. I think that might be more helpful than me doing this in real time. We're going to do this exact same fold on each of the 30 strips. Let's take a closer look at one of these strips. We have this little pocket on one side and this little tab on the other. This is how the strips are going to fit together. I've already got one of the tetrahedra put together. If we look at one of its vertices, we can see the 3 strips interlocked in this pocket tab fashion. I'll show you how to do this with the orange strips. Theoretically, I think that you should be able to do this whole model without tape, but that seems like too much of a challenge for my first attempt. I found the tape especially helpful here at the beginning. Okay, so you're going to want to start by making one full tetrahedron, as I did with the pink strips. This will form the base of the model. Then you'll need to make one point of all of the other tetrahedra, like we've done with the orange. One by one, we'll insert a point into the model, and then weave in and secure the other edges. The first point that you insert is actually not that difficult. I was really second guessing myself as I was doing it, but the result should be like a 3D Star of David, or an hourglass if you pull it out. 2 tetrahedra where each one pokes out of the base of the other. Once you've got this shape, the hard part really begins.
Okay, so I've got this. And now I want to add the other 3 to this. So here comes the hard part. Well, I also have I need these guys. my little points. So now I just have to add them in and then glue on the rest. Okay. What should we do first? Yellow? There we go.
Okay, so I got the yellow point in. I modeled it after this picture. The orange is the red in the picture, the pink is the green, and the yellow is the purple. What I have to do next is weave in the other edges of the yellow tetrahedron and tape them in place. At this point, I have all of the yellow pieces in. Those of you who are experienced in the ways of the 5 intersecting tetrahedra may have already spotted what is wrong with this picture. I believe that the problem is right here. Unfortunately, I did not notice anything off at this point while I was making it, so I kept on going, blissfully unaware that I had made a mistake. It was getting late, so I called it a day and decided to finish up the next morning. With a fresh set of eyes, I got back to work. I started by putting the blue point in. My intention was to follow this picture from Tom Hull's website. I think it works if we take this, maybe rotate it. Okay, yes. So here the pink is red in the picture and the blue is green, the yellow is blue, and the orange is purple. Then I set about putting in the other edges of the blue tetrahedron, not without much confusion. After I finished putting all the blue edges in, I took a look at the model and realized something was wrong. It was pretty asymmetric. In particular, there's a problem right here. If you compare this model to the picture on the right, with my pink as the orange in the picture and my blue as the yellow, you'll see that the orange should not be going under the blue right here. There were some other faces that were messed up in the same way, so I had to go through the entire model and fix all of the faces according to this picture. Unfortunately, I had used tape on all of the vertices, so with each joint that I needed to take apart, I had to peel off the aforementioned tape in order to change the crossings. For this reason, I might recommend that if you do decide to use tape, wait until you have all of the edges of the tetrahedron in before taping them. After figuring out the whole debacle with the blue, I was back on track and able to get the purple in no problem. See the little star on that face? The picture that helped me catch the mistake earlier was extremely helpful as I was inserting all of the purple edges. And so, without any more catastrophes, I was able to get the purple tetrahedron all put together. And with that, the model is finally finished. I really enjoyed turning it around to each face and seeing the 5 points of the pentagon. So the inspiration for this shape is the dodecahedron, which has 12 pentagonal faces. The dodecahedron has 20 vertices, and the tetrahedron has 4. So 5 tetrahedra have 20 vertices in total. And we can place one tetrahedral vertex on each vertex of the dodecahedron. This means that if we were to connect each vertex of the model with a piece of string, we would make the skeleton of the dodecahedron with pentagonal faces. Very cool. Okay, that's all I have for you guys today. Go ahead and give this model a try. It seems daunting, but it actually makes for a very fun challenge. The interesting part is discovering the symmetries of the model by creating it. I encourage you to view it as a puzzle meant to challenge your ability to visualize symmetry. I will link all of the resources that I use down below. As always, thank you for watching, and keep exploring.